Welcome to STEM Professionals. In this video, we'll discuss two important things. The first one is average speed. The next one is average velocity. So let's start with the video. So as of now, we have discussed the terms like position, distance and displacement. Now the next step to define the motion of a particle is to consider how rapidly an object moves. For example, how far does an orbiting satellite travel in 1 minute? Or like how much time does it take for a person to reach the office from his home? So these are the example of some of the most basic questions regarding motion. And in this video, we'll learn how to answer them. So the first term that we'll discuss in this video will be the average speed. And the next term will be the average velocity. Now this question is based on average speed. Now after watching the video, you will be able to give the answer for this question comfortably, but at the end of the video. So we'll discuss this question at the end. Now let's start with the first term, that is the average speed. Now the simplest way to characterize the rate of motion is with the average speed. Now what is average speed? So average speed is basically the ratio of the distance and the elapsed time. So we can write now you can see that this is the formula for the average speed. Now if you see the dimension for the average speed, this is distance, so dimension for distance is L and the dimension for time is T. So the dimension for the average speed is L over T. Now if you see the SI unit, the SI unit for the average speed is meter per second. Now few things you should note about the average speed. These are very important. Now here you see that the distance cannot be negative, it always be positive, and time also it cannot be negative, it will always be positive. So the average speed will always be positive. Now let's take an example to understand this term better. Now in this video we see that a dog run back to its owner with an average speed v, and the distance between the owner, the initial distance between the owner and the dog is d. Now in the question we are given that the average speed is 1.40 meter per second, and let the distance between the owner and the dog is 2.3. Now we need to calculate how much time does it take for the dog to reach to its owner. So this question is pretty simple. We can use the formula that we discussed earlier. So speed we have distance over time, the elapsed time. Now speed we are given to be 1.40 meter per second. Distance we have 2.3 and the unit is meter. This is meter here. Divide with the time. So from here we can easily find out the time, that is elapsed time. So that would be equals to 2.3 meter divided by 1.40 meter per second. And on further solving, we'll get this answer to be 1.6 second. So the time that the dog will take to reach its owner will be 1.6 second. Now next we're going to discuss the term average velocity. Now this is another physical quantity that is often more useful than the average speed, and it is defined as a ratio of displacement over elapsed time. And displacement we have discussed earlier, it is xf minus xi, the final position minus the initial position, and divide by the elapsed time. Elapsed time is the final time minus the initial time. That we can also write it as delta x over delta t. Now if you see the dimension for average velocity, the dimension for displacement is length, and for time it is t. So the dimension for the average velocity would be L over t, and the SI unit for the average velocity is meter per second. Now let us see some important things about the average velocity. So average velocity tells about two things. The first one is it tells that on an average how fast the thing is moving, and next it tells that the direction in which the object is moving. For example, if an object moves in a positive direction, then we can say that xf, that is the final position, will be greater than the initial position xi, and the average velocity would be positive. So this would be positive in this case. Now if the object moves in the negative direction, so we can say that xi, the initial position, will be greater than the final position xf, and in this case the average velocity would be negative because this displacement is negative. So the average velocity tells about two things. First, it's average on an average how fast the object is moving. Second, its direction. Now let us write important note about the velocity. So average velocity is one-dimensional vector. It is vector because it have the magnitude also and the direction also. And the average velocity gives more information than the average speed. Hence, it is more frequently used in physics. Now to understand this term better, let us take one example. So this is the example, and here we can see that an athlete sprints in a straight line for 50 meters and the time taken is 8 seconds, and then he walks slowly back to the starting line in the time interval 40 seconds. Now we have to take that the sprint direction is positive, and then we have to solve these three parts: 1, 2 and 3. Now in the A part we have to find the average sprint velocity, in the B part we have to find the average walking velocity, and in the C part we have to calculate the average velocity for complete round trip. So we'll be solving the A part first. So first we're going to sketch this coordinate system, and for the A part, this is the initial position and this is the final position, and this direction we have taken to be positive. This is the sprint direction. Now we have to find the average sprint velocity. So average velocity that we discussed earlier, it is equals to delta x over delta t. This thing we have studied. Now delta x means xf minus xi divided by delta t means tf minus ti. Now here this would be ti, the initial time, and this is 0 seconds, and here tf, we are given in the question to be 8 seconds because it takes 8 seconds to reach from this point to this point. So average velocity would be equals to, now xf, so xf we have 50 minus xi we have 0 divided by tf we have 8 minus ti we have 0. So that would be equals to 6.25 meter per second, and this value is positive. That means the direction of the velocity is towards this side, the positive direction. So this is the answer for the A part. Now next we're going to solve the B part. Now in the B part, the athletes walk back to its initial position. So it moves like this. So this, in this case, this would be xi, and here this would be xf, the final position, and this would be the ti, that is equals to 0 seconds, and here the final time that we are given in the question to be 40 seconds. So tf becomes 40 seconds, and we're going to apply the same formula. So average velocity is delta x over delta t. Now delta x we have xf minus xi. So xf we have 0, minus xi we have 50, divide by tf minus ti. So tf we have 40 seconds and ti we have 0 second. So that would be equals to negative 1.25 meter per second. And here this negative sign sign denotes that the direction is opposite to the positive direction. That is, we have taken this direction to be our positive direction. So the average velocity comes out to be negative. That means the direction of the body is towards the opposite to this direction. So this is the answer for the B part. Next, in the C part, we have to find the average velocity for the complete round trip. So first, the athlete runs in this direction and then he walks in this direction. And this is the initial position for the C case, xi. And the final position is also this point, this is xf. Now if you see the formula for the average velocity, it is delta x over delta t. Now here we see that delta x is 0 because xf and xi is at the same point. So this would be 0. So that means the average velocity would be 0. Now let us compare this average velocity with the average speed. Now if you find the average speed for the case C, so average speed we know it is the total distance traveled divided by the total time, or you can say time elapsed. So total distance, the body moves in this direction, so the distance traveled is 50 meter and time taken is 8 seconds. Now next it moves in this direction, so the distance would be 50 meter and time taken we are given to be 40 seconds. So that would be total distance would be 100 meter and total time is 48 second. So that is equals to 2.08 meter per second. Now here we see that this average velocity goes to 0. This is 0 here, but the average speed is not 0, it is 2.08. Now I hope you are clear with the difference between what is the difference between the average velocity and the average speed. Now let's get back to the equation that I discussed in the starting of the video, and this was the equation, and the equation says that you drive 4 miles at the speed of 30 miles per hour, then another 4 miles at speed 50 miles per hour. Now there are two parts in the equation. In the A part they are asking that the average speed for the trip 8 mile is greater than, less than or equals to 40 miles per hour. This is what they are saying. Now at the first look it seems that the average speed is 40 miles per hour, but if you observe carefully, the car travel same distance, that is 4 miles, but at different speed. In the first case it traveled at 30 miles per hour, in the second case it traveled at 50 miles per hour. Now let me show this on the figure. Now here you see that the car travels 4 miles at the speed 30 miles per hour, and next 4 miles at the speed 50 miles per hour. So suppose the car took t1 time to travel in the first case and t2 time for the second case. Now logically the time t1 should be greater than t2, because here speed is less and distance is same, and here in the second case also speed is more but the distance is same, so t1 should be greater than t2. Therefore we can conclude that you will be traveling at a lower speed for a greater period of time, and hence the average speed should be less than 40 miles per hour. So the answer for the A part, it should be that this average speed is less than 40 miles per hour. Now in the B part we have to give the explanation, and there are 3 options given. So this option is wrong, this one is wrong, you will go further during the 50 miles per hour and parts. This option is also wrong, because the average speed is not greater than 40 miles per hour. Now third option says that you spend more time during your trip traveling 30 miles per hour, and hence the average speed is less than 40 miles per hour. This option is correct, that we have explained earlier also. So this was the solution. Now if you want me to prove it mathematically that the speed is less than 40 miles per hour, I can do that also, but for that you have to comment me in the comment box below. So okay, this is all with this video, and in the next video we'll discuss the topics like graphical interpretation of average velocity, instantaneous velocity, and so on. So we'll meet in the next video. Thank you.